Suppose you have a bag, and in bag there are five balls, and in five balls there are four balls that have white in color, and one ball has blue in color. So you have to pick a ball to get a blue ball. But when you pick first one, it is white, and then you try one another, and eventually you will get the blue ball. But what if we just put our hand into it, and we at once we get the blue ball itself? So the solution of this problem, and way to get the blue ball at first instance, is the quantum computing, or you can say quantum computers can do it. So let us know what quantum computers do and how it processes information. Okay, first we try to know few facts about it, why it is in talks in nowadays, and why it is so important, quantum computing. So let us try to see what are the initiatives that the various governments have took in the field of quantum computing. Recently, in 2018, America has spent, or you can say, invest 1,200,000,000 dollars in quantum computing technology, and it has also passed a law called the National Quantum Initiative Law. And China in 2016 has focused on quantum communication, and Britain in 2013 itself passed a national policy related to quantum computing, and Canada has also invested 5 crore dollars in quantum computing technology. uh, Let us try to see what is quantum computing, and what is the background of quantum physics. So in 20th century, when Einstein gave his theory of relativity, the first time quantum physics came to limelight. uh, so what quantum physics says? Quantum physics says, as suppose there is a particle in a room at a corner, and you have to find its probability of there after 5 minutes. So there is, in quantum physics, there is no fixed position you can find of any particle. There is always a probability, and on the basis of that probability, we can assume that, okay, this is the area where this particle can be found at some point of time. So this is the very basic of quantum physics. Let us take one more example of quantum computing, how it works, and let us simplify a little bit of it. Suppose you flip a coin, and when we flip a coin, we get head or tail. There are only two possibilities, that either we get head or we get tail. But in quantum computer, if we flip a coin, the quantum computer process the information in such a way that the two possibilities are simultaneously reflected in its process, and quantum computer can see both of them, head and tail, simultaneously. So this position, it is called, you can say, superposition. So superposition is a position in which quantum computer can find the information simultaneously, uh, as compared to normal computer, which will give either head or tail of that result. Or in quantum computer, it will have both the information of head and tail simultaneously. So this is the basic of quantum computing. Okay. So quantum computing uses qubits as its basic unit of information, and it has three parts. One is qubit, another is method for transferring signals to qubits, and third one is classical computer to run a program and send the instruction. So this is about quantum computers. And what are qubits? Qubits are subatomic particles, such as electron and proton, while a bit represents a stream of electrical signals that go to qubits. And in representation of 0 and 1, you know that in binary system, 0 and 1 are the two signals that are used by the computer. In normal computer, it's also in normal computers also, information is coded in the form of 0 and 1. But what is the difference between normal computer and supercomputer? Both uses 0 and 1 as the source of information, or you can say the electrical signals that is transferred in the form of 0 and 1 in both the computers, in normal computer and in supercomputer, you can say quantum computer. So what happened that in normal computer, 0 and 1 are processed differently in normal computers, but in supercomputers, that is in quantum computers, 0 and 1 both can be processed simultaneously. And this is the reason that the supercomputers are can work so fast as compared to normal computers. So what is superposition that the quantum supercomputer uses? Superposition is a position in which the quantum computer can process the information simultaneously, as I mentioned earlier. So in superposition, there is a qubit, and in qubit there are bits too. One is 0 and another one is 1, and 0 and 1 is placed inside a qubit. And in quantum computer in superposition, a quantum computer process the information in such a way that it process all the possibilities of the result simultaneously, so that it can provide the result fast, a million times than the normal computer. Suppose if you suppose you have a complex mathematical problem, and a normal computer have to solve that problem, and if and you have a supercomputer. In supercomputers you can solve the very difficult, or you can say very complicated problem in fraction of unit of time, but in a normal computer that problem will take even hundreds of years. So this is the main difference between a supercomputer and a normal computer. So what is entanglement? So entanglement is the ability of quantum particle to correlate their measurement results with each other. So suppose there are two, suppose I mean there are two particles that is coded as 0 and 1, and entanglement is the ability of quantum particle to relate one another's information, uh, so that if we know the information of one bit, we can automatically know the information of another bit. So this is called entanglement. That is the ability of quantum particles to correlate their measurement results with each other, so that we can get our desired result so quickly as possible. This was all about superposition and entanglement, and so yeah. Okay, so let us try to understand what are the applications we can use out of it quantum computing. So there are a lot of applications we can use using this quantum computing. I mean, you can't even imagine that how quantum computing can help us in future. Till date, there's or you can say in near future we won't be able to use quantum computers normally, but let us hope in future we can use quantum computers for research purposes, and for securing our data, and communication, and mathematical problem solving, etc., etc. So these are the few areas where we can use quantum computing. One I can explain this taking one example. Suppose you want to send your information to another person. In normal circumstances, what happens that the information is encrypted, and it is sent to the other person, and but it can be hacked in some or the other way. But in quantum computing, this information is next to impossible to hack to this information, because it is coded in the form of zeros and ones in such a way that for normal computers to encode this information, it will take nearly hundreds of years. But using quantum computing, we can encode this information in fraction of seconds. So this is the way we can secure our communication and data. So it can be also used for machine learning, as you can say that machine learning is the future of the mankind, and it can also be used for mathematical problem solving, complex problem solving, and the main one major ex- one major application I can assume is that the combination of elements in such a way that it consumes lesser energy as compared to normal condition. One example I can take that. For example, in making of fertilizers, or normally urea, you can I can tell you that energy that is used in producing urea is about 1 to 2% of total world's energy that is used in making of fertilizers. But in if we do it using quantum computing, so what quantum computing do here is it combines the elements in such a way that it requires lesser energy, and it better. For example, if we can make ammonia using quantum computing, it will save world's energy that can be utilized for some other purposes. So this is the application related to complex molecular formation, and yeah, these are the few applications that can be used using quantum computing. But there are a lot of challenges in quantum computing, and a lot need to be done in this field, because it is not the cakewalk to do. And there are a lot of challenges. One challenge is to maintain or find the superposition of bits. This is the main challenge. And another major challenge in supercomputing is building of qubits. At present, there are scientists working on it, and they can make 10 or 20 qubits, but it needs more than lakhs of qubits to make it happen of computer. So this was all about quantum computers and quantum computing. I will be there for with the next video. Till then, bye bye.